All right, everyone, buckle up because today we're taking a deep dive into a theory that'll really stretch your imagination.
Oh yeah, we're going way beyond the usual stuff.
We're talking about the idea that space-time, the very fabric of the universe, might not be this fundamental, unchanging thing.
Nope, not at all, in fact.
Instead, it could be something that emerges, evolves, actually gets created from the interactions of quantum mechanics.
It's a pretty wild concept, really makes you rethink some basic assumptions about the universe.
I mean, think about it. We usually picture space-time as this fixed stage, right?
Yeah.
Like a backdrop where all the action of the universe plays out.
Right, kind of a static container for everything.
But what if, instead of a stage, space-time is more like a constantly shifting dynamic tapestry woven from the threads of quantum activity?
That's a much more dynamic picture and a lot closer to what some physicists are starting to think.
So right off the bat, we're diving into some pretty deep waters here. I
Yeah.
mean, quantum mechanics and space-time, these are like the two big pillars of modern physics.
They are, and for a long time, people treated them as kind of separate domains.
Yeah, like two different sets of rules governing different parts of reality.
But now we're starting to see how these two seemingly separate realms might actually be deeply intertwined.
Okay, so maybe let's start by getting everyone on the same page here.
Hmm.
When we say quantum mechanics, I mean, what are we really talking about?
Essentially, the weird and wonderful world of the very, very small, the realm where the rules of classical physics just don't apply.
So like atoms, subatomic particles, that kind of thing.
Exactly. Think of particles behaving not just as little billiard balls, but also as waves spread out in space with their properties like position and momentum, all fuzzy and uncertain until they're measured.
Right, that whole wave-particle duality thing, always a brain twister.
It is, and at the heart of it all is this concept of the wave function. You can think of it like a blueprint for a particle's possibilities, describing everything about it all at once.
And these wave functions, these blueprints, they don't just exist in isolation, right? They interact somehow.
They absolutely do. They overlap, they influence each other, they get entangled in this incredible quantum dance.
And some physicists believe it's precisely these interactions, this quantum dance, that could be responsible for generating space-time itself.
That's the heart of this theory. It's saying that space-time isn't a pre-existing background, but a dynamic product of these quantum interactions.
Wow. Okay, so instead of particles just bumping around in a pre-made space-time container, it's like the very act of them interacting, their quantum relationships, that's what creates the space and time we experience.
Precisely. It's a radical shift in perspective. Space-time isn't the stage, it's the play itself, constantly unfolding, created and recreated by these quantum interactions.
My brain is already starting to hurt, but in a good way. This is
Yeah.
some seriously mind-bending stuff.
It is, and it really challenges us to rethink some fundamental assumptions about reality.
Like even the concept of nothingness, right?
Hmm.
If space-time is emergent, what does that mean for the supposed emptiness beyond the universe? Is there even such a thing?
That's where things get really fascinating. You see, in this picture, there's no need for a pre-existing empty space for the universe to sit in.
So are we saying that even outside the universe, where space-time as we know it breaks down, there's still some kind of quantum activity brewing?
Exactly. Imagine a cosmic soup of photons, the particles of light, and gravitons, the theoretical particles thought to carry the force of gravity. Even in the absence of what we'd recognize as space-time, these particles could still interact.
Okay, and these interactions, they're not just random, right? They have the potential to actually kickstart the formation of space-time.
Precisely. Think of it like a chain reaction. In this pre-space-time realm, photons and gravitons are constantly exchanging energy, and those interactions, under the right conditions, can start to weave together the very fabric of space-time.
It's like a whole new origin story for the universe. Not a big bang from some singularity, but a gradual emergence from a sea of quantum interactions.
Exactly. Instead of an explosion from a single point, it's more like space-time slowly crystallizing out of this quantum fuzz.
So we've got these photons and gravitons kind of setting the stage, creating the scaffolding of space-time. But what about the stuff we're more familiar with, like matter, mass, gravity? How do those fit into this quantum space-time picture?
That's where things get even more interesting. Remember those wave functions, the blueprints we talked about? Mhm. Well, those blueprints don't just describe a particle's position and momentum. They also contribute to its mass.
So mass itself, a property we usually think of as so fundamental, it's also emerging from these quantum interactions.
Exactly. And here's where the connection to gravity really comes into play, because mass warps space-time, right? Creates those curves and dips that govern how objects move.
Yeah, that's Einstein's general relativity in a nutshell. Mass tells spacetime how to curve, and spacetime tells mass how to move.
Exactly. But now, instead of just thinking of mass as some pre-existing property, we can see how it emerges from the interactions of these wave functions, and how those interactions, in turn, shape the curvature of spacetime.
So it's like a feedback loop, a constant interplay between quantum interactions, mass, and the curvature of spacetime. Everything is connected.
Precisely, and it's this dynamic interplay that gives rise to the universe as we experience it.
Okay, my head is officially spinning. But I have to ask, what about time itself? Does it get a makeover in this quantum spacetime world?
Absolutely. You see, in this picture, time isn't just a steady linear progression. It becomes a much more dynamic process, intimately tied to the quantum interactions that are constantly shaping and reshaping spacetime.
Hold on, so you're saying that now, this very moment, isn't just a point on a timeline, it's actually playing an active role in how things move through spacetime.
Think of it like this. Imagine spacetime as a constantly evolving map. Now is like a dynamic cursor on that map, constantly influencing the routes that objects, even light itself, can travel. It's not just a marker of time, it's an active participant in the unfolding of reality.
Wow, that's a pretty radical departure from our usual way of thinking about time. It's like the universe is constantly making choices, and now is the point where those choices become real.
That's a great way to put it. And there's this famous thought experiment in quantum mechanics called Schrodinger's cat. It's often used to illustrate the concept of superposition, where a particle can be in multiple states at once. But it also sheds light on this dynamic nature of space-time.
I've heard of that one, the cat in the box, both alive and dead, until you open it and look inside. How does that relate to spacetime?
Well, think about what happens when you open the box. It's not just that you're observing the cat's state, it's as if space-time itself rushes in to fill in the cat's history, determining whether it lived or died. The act of measurement, of interaction, shapes the very fabric of space-time.
Okay, that's blowing my mind. So are we saying that spacetime is constantly being rewritten moment to moment based on these quantum interactions?
In a way, yes. It's a much more fluid and dynamic picture than we usually imagine.
Okay, so if we take this all the way, what does it mean for the edge of the universe? Is there even an edge if spacetime is constantly emerging from quantum interactions?
That's a question that really pushes the boundaries of what we can know. But if we follow this line of thinking, it suggests that even beyond the limits of our observable universe, where spacetime as we know it breaks down, there might still be a sea of quantum interactions happening.
So what we perceive as the edge might just be a transition zone, a place where our familiar spacetime gives way to something more fundamental, a realm of pure quantum possibility.
Exactly. And it's those pre-spacetime dynamics, those interactions happening in the void, that could be setting the stage for new spacetime to emerge, for new universes to be born.
So to sum it all up, we're saying goodbye to the idea of spacetime as this fixed, unchanging container and embracing a much more dynamic, quantum-woven reality, constantly being created and recreated.
Absolutely. And it's a shift in perspective that opens up a whole new world of possibilities.
It certainly does. I mean, if space-time is emergent, a product of quantum interactions, does that mean we could one day learn to manipulate it? Could we create wormholes, warp drives, things we used to think were pure science fiction?
That's a question we'll have to leave for future deep dives, but it's certainly a tantalizing thought, isn't it? If space-time isn't fundamental, if it's something that can be shaped and molded, who knows what we might be able to achieve?
Definitely something to ponder. Thanks for joining us on this incredible journey into the quantum heart of space-time. And be sure to let us know your thoughts. Until next time.